Hey everybody, this is Mrs. Dinkelman, and these are the notes for lesson 7.1, which is titled Solving Differential Equations and Verifying Solutions. The whole chapter 7 is really about differential equations, which, by the way, are just equations with derivatives in them. There is a semester course at the college level called differential equations, so we're just going to scratch the surface a little bit, talk about what they are, look at solutions, and then and solve them if they are separable. So the procedure here, I kind of made up a new word. I didn't really make it up. I stole it. I don't even know how to spell it. But I'm going to call, what we're going to do is we're going to separate. Okay, separate is really a combination of we're going to separate the variables and then we're going to integrate. And then there are some things to do after that, but that's basically what we're going to do here. So again, we'll kind of maybe come up and look at some of those procedures. One of the things they talk about here is replacing the y prime with a dy dx. That's one of the things that we want to do because that will help us separate the variables a little bit. So on this one, I'm going to first move the x over to the other side, okay? And then I'm just going to multiply both sides by dx, and then I'm going to give us one more bit of advice. So if I multiply both sides by dx, I have that. And just by the way, another reason why I teach implicit the way I do, notice the little dy and the little dx at the end of the statements. So one other thing I think is helpful is to move as much as possible over with the x, or the other way to say that is to leave very little over on the left-hand side with the y, because our eventual goal is to get this thing to say y equals, just like most of our equations. So if that's the case, we might as well go ahead and move as much as possible. So I think what we should have here is we should divide both sides by 2 so that we have that over on the right-hand side. Okay, so that was the separate part of this. We're going to separate and we're going to integrate. So all we're really doing here is if they give us a differential equation, trying to find what the original function is. So we're basically doing an antiderivative just in a more complicated way than we did last section. Okay, so antiderivative of y is going to be y squared over 2. And then for this next one, it's like there's a negative 1/2, and then I can take the antiderivative of the x, and I'm going to put a plus c. Now, technically, it feels like maybe plus c should be on both sides, but I don't really need it to, because what if there was like a plus 2 on this side and a plus 5 on this side? Well, then I could solve and just say, oh, it's a plus 3 over on that other side. So as long as we have our plus c somewhere, then we'll be good to go. All right, our next goal, at least in this one, is to solve for y. Okay, it says it's actually a pair of possible functions. We'll talk about that in a second. So the first thing I think I'm going to do is multiply everything by 2 to get rid of the fractions. And let's see, that's just going to be the negative x squared over 2 plus 2c. Now 2c is technically also a constant, and we could rename it. We probably wouldn't want to call it c again because it's twice the value of the c that we labeled earlier. So you could call it an a or a d or something like that. Okay, so next we're going to square root both sides. So what that means is we really have plus and minus, or positive and negative, square root of that stuff. Now there will be some information later about how we can decide whether it's the plus or minus, but right now we're just doing what's called the general solution. So what we're saying is that if this was the original equation, it fits this kind of equation that they gave us earlier. Okay. Okay, so again, it's a pair of possible functions. One's a positive, one's a negative in there. All right, so this one, a couple of things. It contains a particular point, 0, -3, and it says the slope is that. And remember, that's the same thing as saying dy dx equals that. Okay, but we're going to, instead of finding the general solution with the plus c, we're going to be able to figure out what plus c is because of that point that they gave us earlier. So in this case, I think the easiest way to separate is just to do a cross product here. Okay, so there's the separate part. And maybe another bit of advice now that I'm thinking about it, the dy and the dx need to be in the numerator, not in the denominator. So just be careful as you're doing those. So there's the separate part. Now let's integrate. So y squared over 2 equals, Now this particular problem I'm going to do fairly quickly, but if you want to pause and make sure you know how to do it, really probably a U sub problem. So I think the answer is e to the x squared divided by 2 plus c. Kind of the reason I think that is because the derivative of x squared is this 2 is 2x, which there's an x there, but the 2 somehow goes away. So again, if you want to pause and make sure that you could get that using U sub, then definitely feel free to hit pause and see if you get the same thing as me. Okay, so now we're going to try to figure out what the c value is. Now, some people like to solve for y first and then find the value of c. I'm one of the people who likes to find c first and then solve. So in some cases, one way is easier than the other. I just tend to always find the c value right away and then I solve. Okay, so let's think about this. This is an xy. So when y is -3, we're going to get 9 halves over here, and x is 0, so e to the 0 is 1. So I think c then is 8 halves or 4. Okay, so let me kind of rewrite that there. All right, so similar to last example, I'm going to multiply everything by 2. And then we're going to solve for y, so plus or minus square root. Now this time we have to make a decision. Is it the plus or is it the minus? So we're going to look here at this original and see that our result should be a minus. And the only way we're going to get a minus or negative out of a square root is by having the negative. So I'm just going to go ahead and erase that positive here. We just need the negative root of that particular thing. Okay, so just a little bit more practice with all of these. So general solutions, those are going to be the ones where we leave the plus c. Particular solution, we're going to actually find out what the c is. So let me work through here and see what we can do. I kind of like that there's the x and the dx on that side, but notice the dx is in the denominator, and that's no good. So my brain is first going to multiply both sides by dx. And then I like that the dx and the dy in these cases are in the numerator, so it's those other things I have to swap. So I'm going to divide both sides by x and also divide both sides by y minus 2. So it's going to be dx over x and then dy over y minus 2. Now I kind of want that. I want the y's on the left because that's what makes sense to my brain. So I'm just going to do that really quick. So that's the separate part. Again, we want to make sure that algebraically we're not doing any moves that are incorrect. So we got to be really careful about our algebra here. Now, since we have a y to the 1 and an x to the 1 in the denominator, these are going to be our natural logs. Oops, equals. Okay. Now, the way we're going to solve for these is we're going to go ahead and e both sides because we're trying to solve for y. I'm going to go ahead and drop those absolute value bars there. We would have to definitely double check that that would work out for us, but we're going to do that for now. We could always go back later and change. So the issue here that I generally see is that plus c is now up in the exponent. In fact, maybe what I should do is put parentheses here. All of that is up in the exponent with the e. So we're going to talk about what we could do with that, and then let's add 2 to both sides. So e to the ln x plus c, and then plus 2. Okay, they might simplify this, so I just want to talk about this for a second. So exponent laws. When we add exponents, it's because we had something where they were multiplied together with the same base. Okay, so that is the same thing. So e to the c, by the way, is also just a constant. E to some number is going to give us a number. In our textbook, a lot of times what they do is call that like an a. They don't want to use c because we've already used c. And then e and ln are inverse functions, so they cancel each other out, and we'd just be left with the absolute value of x there. All right, so then same problem on b, but they give us more information. Now, I don't know, because I already have it sort of solved, I probably won't go back and try to find c before I solve it. So let's go ahead and use this that we got from part A to see what's happening. Again, this is backwards from how I would normally do it. I would usually try to find the c value first and then solve for y, but that's okay. So in this one, the y is a half, bx is a 1. Okay, so a must be -3/2. So let's see how that works out. So -3/2, absolute value of x plus 2. And let's just double check that when we plug that in, that's going to work out, because again, that absolute value at the beginning kind of made me a little bit leery. I think we're good. Okay, so now we're going to talk about what it means for something to be a solution. What we were actually finding were solutions. Sometimes they ask us a question where they just have to verify if something is a solution. So it's just like in algebra when we found x equals -2 as a solution, how we would plug in the solution to verify. Sometimes we call these zeros, which is fine. So -8 plus 4 plus 4 equals 0. So that's how we checked if it was a solution. This time, the problem is the solution's just a little bit more complicated. So what we're going to try to do is plug this into that and see what happens. And we can actually plug in for the derivative as well. So I'm just going to go ahead and quick find the derivative, and then we'll kind of put pieces together to see what it looks like in that equation. So this derivative is just going to be 1/2 e to the x plus e to the -x times -1 because of the chain rule. And I'm going to try to plug the pieces that I know into that equation now. That's the differential equation. So on the left-hand side, I'm supposed to put y prime. So 1/2 e to the x. I'm going to just call this minus e to the -x equals. And this is kind of our question mark, right? We're hoping they're equal, but we're just going to double check. It's going to equal e to the x minus, and just the original y. So let's see how that works out for us. Okay, so I feel like I need to simplify the right-hand side just to verify. So these two, I can add those like terms because they're both e to the x's. So that's positive 1/2 e to the x, and distribute the minus sign, so negative e to the -x. Yes, they are the same. So I just like to put a check mark at the end like, yep, I checked it, and it worked out. Okay, so on the assignment, I don't think there were any we were skipping, but let me look really quick. So again, general solution, those are going to be the ones with the plus c. Particular solution, you're going to find the plus c. And, oh, and remember advice, anytime you see y prime, don't forget to change it to dy dx, for instance. I just wanted to see if there are any of the, determine whether each of the following is a solution. So on this one, 10 through 13, we're going to do that same thing we did in the very last example, which is find the second derivative in this case and see if it matches that relationship. Okay, I don't think I had any crossed off, so go ahead and get started on 7.1.